Hello everyone, welcome to Young Innovators. In this video, we will look into some electronic components, its working and build some circuits using the same. Now, let us see what are electronic components, why we need them and where it is used. Electronic components are the building blocks of every circuit. It is a collection of devices like resistor, capacitor, transistor, diode, sensors, and the name goes on. There are about hundreds of components available. When these electronic components are put on a circuit board and connected together, it forms an electronic circuit, and each of the components perform a specific task in the circuit. The first electronic component was invented by E.G. von Keilst and Peter van Musschenbroek of Leyden in the year 1745, and it was named Leyden jar. It was the first device to store static electricity. It consists of a glass jar with a metal foil connecting the inside and outside surfaces and a metal terminal projecting vertically through the jar lid to make contact with the inner foil. There are two types of electronic components, namely an active component and a passive component. An active component is a component that consumes the energy in form of voltage and supplies to the component in the form of current. They require external energy source to operate or function. Some examples of active components are transistors, integrated circuits, etc. Moving on to passive components, a passive component is the one which consumes the energy provided to it. Passive components do not depend on the external source of energy or voltage to perform a specific task. Most commonly used electronic components are LED, resistor, capacitor, diode, transistors, etc. In today's video, we will look into three major electronic components, that is a diode, an LED and a resistor. So let's look at the diode first. A diode is a two-terminal device that lets current to flow in a single direction. It is commonly made of semiconductor or vacuum tubes. A vacuum tube diode consists of two terminals, anode and cathode, kept in a vacuum glass tube. A semiconductor diode has a p-type semiconductor where the number of holes are more and n-type semiconductor where electrons are more. Hence, it is known as a p-n junction diode. The semiconductor used mainly would be silicon, but you can also use germanium or selenium. The terminal on the p side is called anode and the terminal on the n side is called cathode. When the anode is connected to p side and cathode is connected to n side, the diode conducts and it is told to be in forward bias. When the connections are reversed, the diode does not conduct and it is told to be in reverse bias. Diodes are found in many applications of a circuit, like in a rectifier. The diode is used to convert alternating current to direct current. In a clipper circuit, the diode clips the signal to a desired value. Let us build one circuit using the diode now.
I take the components that are a diode, a bulb and a battery and place them on the workspace as needed. And from the positive end of the battery to the anode, and from the cathode let me connect it to the bulb, and from the bulb let me connect it back to the battery. This completes the circuit, and now when I click on start simulation, the bulb glows. So this tells us that the diode is letting the current to flow through the circuit. So by this circuit we understand how the output is dependent on the direction of the current flow when we use a diode. Let's look into a type of diode called LED. A LED is a light emitting diode. It is a semiconductor diode that emits visible light when an electric current passes through it. LEDs come in variety of shapes, size and color. The symbol of LED is as shown. Like a diode, LED also has two terminals, that is anode and cathode. And here are the three ways to identify these terminals in the LED. 1. Longer lead indicates anode and the shorter lead indicates the cathode. 2. At the cathode, the metal plate is larger and at the anode, the metal plate is smaller. 3. The cathode has a flat edge and the anode has a round edge. LED has wide applications in the places like home lighting systems, display boards, traffic lights and alert systems. Now let us see how LED work when I connect it to a battery. So let's get back to workspace and drag the LED and battery on the workspace. The slightly bent terminal is the anode and the straight terminal is a cathode. Let me connect the anode to the positive of the battery and cathode to the negative of the battery. And when I simulate the circuit, the LED burns. This is because the current flowing through the LED is more than it is needed. The voltage in which any LED operates is around 3.6 volts and anything above that causes the circuit not to work. So let's see if it works with a 1.5 volt battery. Let's connect the LED to 1.5 volt battery. Still the LED will not glow because 1.5 volt is too less for the LED to work. Hence, it is important to provide the necessary voltage for the LED to function in a given electrical circuit, providing the required amount of voltage for it to work. What happens if I connect two batteries to the LED to provide the necessary voltage? It burns due to improper connection or current flow in the circuit. And if I connect two batteries to the LED will burn. So let's identify the components which can control the current flow in the circuit and allow the LED to function properly. A resistor. As the name says, resistor resists the current flow. It can control the current flow and hence allow the LED function properly. Resistor is a two-terminal device that resists the current flow and controls the current flowing in the circuit. The resistance of a resistor is measured in ohms. The symbol of resistor is as shown. The values of resistors based on the color band printed on the resistor. Each band on the resistor has its own identification. So here we have used 4-band resistor and the first band of the resistor tells the first decimal point, the second band tells the second decimal point, the third band tells us the multiplier value and the fourth band tells the tolerance value. So now let's introduce a resistor to the circuit. Choose a resistor, connect the positive end of the battery to one end of the resistor and other end of the resistor to the anode of the LED. The current flow to the LED is controlled by the resistor placed in between and the circuit work without any difficulty. And the intensity of the LED is bright.
Let us see how we can connect LED with slide switch and press switch. A slide switch is a two-position, three-terminal switch that controls current flow in the circuit. We can let the current flow through the switch by sliding the knob to either of the ends. There are three terminals in the slide switch and the middle terminal is a common terminal. We use either the first two or the second two terminals for the circuit. And here I drag the necessary components that are an LED, a resistor, a battery and a slide switch and connect it as shown. And now when I slide the knob of the switch from one end to the other, the LED glows. And by sliding it to the other end again, the LED does not glow. So this explains us how we are able to control the current flow in the circuit. Next, let us look at a similar circuit where I replace the slide switch with the press switch. A press switch or a push button is a momentary switch which causes a temporary change in the state of the electrical circuit. And here I take the components needed, that is LED, resistor, battery and a press switch, and connect it as shown. The LED glows if I press the switch and does not glow on releasing the switch. So this explains us how the output change is seen from a press switch for the temporary time. In today's video, we learned about components like LED, resistor, diode and built circuit using the same. Hope you guys enjoyed watching this video.